selected 3 compounds which have totally different maximum residual limit. As I said, selection of the concentration levels will be based on the maximum residual limit for the target analytes. Chloramiphenol, thiamiphenol, fluorophenols, these are veterinary drugs in food of animal origin. Here maximum residual limit for chlorophenol is 0.3 ppb, very low maximum residual limit, or we can say minimum performance required limit. Here 50 ppb for thiamiphenol, maximum limit for fluorophenols is 200 ppb. This I selected for this compound because it's very low. I selected 0.1 to be the lowest concentration required, or the lowest level or quantitation limit, 0.1. I ran 10 replicates, then I got this result. These results. I can use this as an example here. Then you will calculate the recovery for each concentration divided by this. Enter. Here convert to multiplied by 100. And calculate the average for the result, average between result. Calculate standard deviation. Then calculate relative standard deviation, which is equal to standard deviation divided by the average multiplied by 100, or we can convert from format cells. And format cells convert to percentage. Here percentage can only take 18%. This is the relative standard deviation. And then we can calculate LOD. LOD equal to blank plus 3 standard deviation, so equal to 3 multiplied by standard deviation, enter, 0.048. We can format cells number 2 decimal point, 0.05. This will be your LOD detection limit for this compound as example. But here you can see recovery. I calculated recovery. If you want to calculate relative standard deviation using the recovery, so you can standard deviation from the recovery divided by the average of recovery, it will give you the same value as here. Then you calculate LOD as I told you. That's all for also other compounds, thiamiphenol and fluorophenols. Thiamiphenol 50 ppb, so if you divide it by 10, it will be 5 ppb. So I selected 2 ppb to be the lowest level. And for fluorophenols, if you divide 200 by 10, it will be 20. So I selected 10 ppb. It's enough. 10 ppb as the lowest level, and I calculated by the same way. That's for the low level. For the high level, same thing you will do. You will calculate the average and the standard deviation and the relative standard deviation between all of these levels for all compounds. High level, I selected 5 ppb for chloramiphenol, which is higher than the minimum performance required limit. Thiamiphenol 50 ppb, same like the maximum residual limit. For fluorophenols, I selected 200 ppb, which is the same also like maximum residual limit. For mid-level, I selected in between, so I selected 1 ppb. That's also higher because 0.3 is very low. In this case, you can do this, 1 ppb. Thiamiphenol 25 ppb, and for fluorophenols 100 ppb. So you should cover the most important thing. You should cover the range of concentration or range of interest, range of concentrations expected to be measured by the method for your target analytes. I finished all levels, low level, mid level, and high level. I calculated average standard deviation and relative standard deviation for each level, for each compound, if you have different compounds. Then for trueness, I got here one example for you, chloramiphenol. Chloramiphenol PT, I select PT, that's real PT, and that was the assigned value from the certificate, 0.746. And here PT result, or we can consider this sample as CRM after we got the result from the provider. CRM 0.65, 0.71. These are the concentration. I ran this sample 10 times. I got the result. Then number of replicates 10. I should calculate also at the beginning the recovery. Recovery should be within acceptable range. If this, as example, 0.4. Recovery will be 53. That's not accepted. So all of recovery should be within acceptable range at the beginning. Then you will calculate the average. I can take this result to explain. You will calculate the recovery, as I told you, this result divided by the assigned value result multiplied by 100. Then format cells number 2 decimal points. Okay, then you can calculate the average between all results. .72, and here also the average between for recovery. Then calculate bias. For trueness, we will calculate the bias, which is equal to assigned value minus the average divided by assigned value or reference value divided by assigned. Enter. This is the bias. We can also multiply bias to get bias percentage. To get bias percentage for format cells, percentage. Okay. Then calculate standard deviation also. You will use it. Standard deviation. Between these results. Then you can calculate now bias uncertainty due to bias. Uncertainty due to bias, which is standard uncertainty. Uncertainty due to bias equal to standard deviation divided by square root of n. Square 10 replicates, so enter. This is the uncertainty due to bias, which also can be converted to percentage. Then relative standard uncertainty, which is equal to uncertainty due to bias divided by average of recovery. Enter. .02%. This is the relative standard uncertainty that will be added to the final result with the uncertainty combined. So that's up to here. We calculate the trueness. We evaluate the trueness, and also we evaluate the trueness from bias percentage. It should be less than 100%. Bias 3.75 should be less than 20%, and we calculate relative standard deviation for each level that will be used after that to calculate the pooled relative standard deviation. Have CRM for your target analysis to evaluate the trueness. In this case, you will get the result from 3 levels that you already analyzed and you already prepared. For chloramethnicol, you did first low level, mid level, and high level, and you got these results. As example, I add this concentration from it was 70% for not concentration recovery. Mean recovery, the average recovery for the low level was 70% for chloramethnicol in case of low level. In case of mid level was 82%. Third level it was 84%. So the lowest one or the worst recovery I will select. In front of this recovery you will find standard deviation equal to 4. So I can select this one to be used to evaluate the trueness. Uncertainty for recovery or uncertainty due to bias, which is standard uncertainty, equal to standard deviation from the low level divided by square root of n number of replicate, which is 10, and relative standard uncertainty equal to uncertainty due to bias divided by average recovery. Average recovery also it will be multiplied by 100. Then for this compound also, this compound for fluorophenols, that was the average recovery for the mid level, for the second level was here was low, but here was 85%, here was 98%. So I selected this, the worst recovery. For thiamethnicol, 92%. For the low level, 92%. For the mid level, 79% for the third level. So I will select this one. So now, if you don't have CRM for your target analyze to evaluate the trueness, you can use the 3 levels or the 4 levels, whatever number of levels you prepared at the beginning to evaluate repeatability and reproducibility. You can use them also to calculate the relative standard uncertainty and evaluate the trueness, and calculate also the bias percentage. I will calculate pooled relative standard deviation, and also I will calculate recovery Q-type. Q-type, which is the average of recovery between all of 3 levels. If you calculate for chloramphenicol, I got 88%. For low level, 98%. This is the average of recovery for the low level. Mid level, 98, 91%. So the average between all of them, average for all of them will be 92%. That's not mandatory to do, because if the recovery was accepted for the low, mid and high level, so the average of recovery also will be accepted within acceptable range. But the most important part to calculate pooled relative standard deviation that will be added at the end to the uncertainty combined. I selected relative standard deviation 1 from the low level, relative standard deviation 2 mid level, relative standard deviation 3 from the high level, which here equal 18%, 15%, 7%. All of them should be less than 20% to be accepted within acceptable range, according to the matrix analyzed or the guideline used. Sometimes you will find higher than, according to the matrix, it will be higher than 20% or less than 20%. So I will calculate from this equation the pooled relative standard deviation. You will apply here. That also should be less than 20%. I calculate relative standard deviation pool that will be added at the end to the measurement uncertainty for calculation to represent the random effects on the result. I will take these results and calculate uncertainty, but here I calculated only for type A evaluation, not type B evaluation, and I selected 10% for sample processing. But after that, as I told you before, inshallah, I will prepare a lecture only for how to calculate measurement uncertainty for sampling. It will be very, very, very interesting lecture. So I got the pooled relative standard deviation for chloramphenicol, fluorophenols, thiamethnicol 17%, 15%, 14%, and the relative standard uncertainty 0.02%, 2.44%, 0.36%. Then I calculated the combined uncertainty for each one of them, which is the square root of all of them, and here expanded uncertainty, which is uncertainty for combined multiplied by 2. As I told you, you don't need, it's not mandatory to calculate measurement uncertainty for type B evaluation, because in type B evaluation you will get the uncertainty from the certificate for other equipments, assisted equipments like micropipette, balance, other equipments. These equipments you already use through during repeatability and reproducibility to calculate the pooled relative standard deviation or to check all of this for validation. So you don't need to do also type B evaluation, and it will be very low amount. So if you want to use, you can use also, but here I calculate only using type A evaluation. To the lecture, I hope that was helpful for you, and please, if you have any question related to this lecture or other lectures also, don't hesitate to ask, to leave a comment, and don't forget to like, share and subscribe on my channel. Thank you, and see you in the next lecture inshallah. Assalamu alaikum wa rahmatullah.